Hello, everyone. Nice to meet you again. This is a solution of 30 questions in trigonometry and geometry of the SAT exam. All questions from question bank of College Board. Question number one. In triangle ABC, angle B is right. So just to draw a triangle like this and name it ABC, such that B is a right angle. Length of BC is 136 millimeters. Cosine A, this angle A, cosine A 3 over 5, it means the ratio 3 to 5. So the side length itself make it 3n to 5n. What is the length in millimeters of AB? The length of AB here, you can find it by uh, calculating the value of n and then multiply 3 by n. The right triangle with sides 3n and 5n by Pythagorean theorem, you can find this side for n by writing 5n squared minus 3n squared, and you take the square root, you will get 4n. So this 136 is actually 4n. So if you want to solve n here, 4n equals 136. So the n equal 136 divided by 4. What's the answer? 136 divided by 4, answer is 34. So if n 34 and you would like to find the length of AB, the AB is 3 times 34 will be 102, something like that. Okay, if you have easier method to solve it, just write in comments, please. Let me share our ideas together. Measure of angle Z is 60 degrees. What is the measure in radian of angle Z? So if you want to convert the degrees to radian, just multiply it by pi over 180. The answer is pi over 3. So the answer is 1/3 pi. Okay. Question number 3 here. I have two triangles are similar, and the length and width of the first one is 5 and 10, the other one 12 and what number? Ask you about D. The ratio between length and width in the first rectangle is the same ratio between length and width in the second rectangle. So since the 10 is a double of 5, so this side will be the AD, or BC will double of 12 will be 24, each of them. So AD must be 24. So instead of writing the normal equation, that similarity, the proportionality between corresponding sides, the original solution say that AD over 10 is equal to 12 over 5. I used this one. I used AD over 12 is 10 over 5. Same. You will get the same value. No problem. A cylinder has a diameter of 8. Cylinder has a diameter. The diameter is 8. Its mean the radius is 4. And the height is 12. What is the volume? You know the volume of cylinder, pi r squared h. Just calculate. Pi times 4 squared, 16 times 12. So the product of this will be 192 pi. Question number 4, answer is C. Question number 5. A triangle R has an area 60 square centimeters. Square S has a side length 4. The total area of triangle R is squared. So the triangle R given its area already 80 plus, if you have a square with side length 4 centimeter, so its area will be 4 times 4, 16. So really 80 plus 16, 96. A very easy question. Question number 5 is D. Next one. I have a right triangle. Two sides are given. Ask you about the length of the third side. Direct application for Pythagorean theorem here. A squared is 21 squared minus 6 squared. So the A is the square root of 21 squared minus 6 squared. So answer is A. Question number 7. In the figure shown, triangle JKL is similar to triangle RST, where J corresponds to R and K corresponds to S. The length of JK is 15. JK here is 15 units, and the perimeter of triangle JKL, the perimeter here is equal to 36. The length of RS, the corresponding sides of JK is 135. Of course, the shapes is not drawn to scale. What is the perimeter of triangle RST? The perimeter here, the second perimeter now, you can find it by multiplying the first perimeter 36 by scale factor. because the ratio between parameters is the same ratio between sides, is the same scale factor. So you start the scale factor with the side of the figure you want to calculate its parameter. So start a scale factor by 135 over 15. So multiply this, you will get the value 324. So the answer is A, 324, question number 7. Question number 8, I have a right triangle, 53, the length of hypotenuse, the RS, this one is the square root of 105, something like 10.2, something like that, or 10.1. What is the value of sine R? Sine R, as you know, in the right triangle, the opposite over hypotenuse. The opposite side is unknown, I can find it. TS is the square root of 53 squared minus root 105 squared. This side, you solve it by calculator, you will find it about 52. So if this side is 52, sine R now is opposite side 52 over hypotenuse 53. Okay, thank you so much. That's it. Now I have this figure, Cartesian plane. The 3 points shown define a circle. The circumference of the circle is k pi. So this figure now, you know, any non-collinear points, there is a circle pass through its vertices. So once you draw this side here, and this side here, and this side, this triangle is actually right triangle, as you see here. Okay? Because each of the figures now is to draw to a circle. The circle now, if you try to move it, if you try to move the circle, I try to move, oh, I cannot move it. So if you try to move, to draw a circle, another circle, and this way like this, oh, how to draw to a circle. Oh, okay, let me delete this one. So let me show you something. So this side here, and this side here, and this side here, this, I'm sure that, you know, or as you see here, this side is right triangle. Let me show something for you. This side now, this is really right triangle. So this side represents the diameter of circle. So the circle is drawn like this, something like that. Okay. So this side is actually 1, 2, 3, or the distance between 10 and 2, 10 minus 2. 10 minus 2 is equal to 8. So the diameter equals 8. Simply, that's it. Diameter of circle equals 8 units. A distance from 2 to 10 up here. Okay, thank you so much. That's it. Next question here given. Rectangle ABCD is similar to rectangle EDF. So ABCD, the EFGH here. Area of rectangle ABCD is 648. This is the area. And the area of rectangle EFGH is 72. This is the ratio between areas. The length of the longest side in the rectangle ABCD is 36. This is side. What is the length of rectangle of the I'm so sorry. What is the length of the longest side of the rectangle ABC? It says it's longest side L. You know the ratio between sides is the same square root of ratio between areas. Yeah, that's really true. So L over 36, the same root 72 over root 648. So to find L here, just multiply by 36, multiplied by 36. So the L is, you can do this by calculator, you will get the value. Question number 10, you found it will be 12. Okay? Will be 12. You can try. Because the ratio between this one and the ratio here between the side lengths, I mean 36 over the scale factor 36 over 12 is equal to 3. This is the scale factor. If you get the ratio between areas, area 1 over area 2, you will get like the scale factor square. Try. I mean 9. So if you divide 648 over 72, you will get the answer 9, exactly 9. So this is the answer. L is equal to 12. So the correct answer here is C. Question number 11, I have triangle ABC similar to triangle DEF where angle A corresponds to D and angle C correspond angle C and F are right angles. The length AB is 2.9 times the length of DE. And the tan A is 21 over 20. What is the value of sine D? Really, the scale factor that the length is twice or double or triple of the other side length, it doesn't affect the measure of angles. So you just draw one of them, one triangle only, and where is the C and F right? So AB like this, ABC because C is right angle, C and F in the other one is right as well. So when I say tan A is 21 over 20, and I ask you to find sine D, the D corresponds to what? A corresponds to D. D is the same as A. So find first the hypotenuse here by writing 20 squared plus 21 squared to get the hypotenuse is 29. And after that, sine D, because D corresponds to A, the same as A. So sine A, as you see, or sine D, doesn't matter, will be 21 over 29. Okay, this is the answer. I have a triangle drawn side inside it. BD is parallel to the base AE. These two triangles now are similar. In the figure shown, triangle CAE is similar to triangle CBD. A measure of angle CBD is 57 and AE is 26 BD. AE is 26. So AE, where is AE? Is 26 values. When you have something like that, AE is 26, BD, give BD always one unit. So the AE will be 26 times 1, which is 26. So the ratio between them is 1 to 26. What a question now. Measure of angle CBD is 57. Where is CBD here? CBD, this angle now is 57 degrees. The question is, uh, what is measure of CAE? This angle is corresponding. This angle and this angle, corresponding angle, they are equal. So the same 57 is very similar question, very easy question. Sometimes give you a ratio here to just stuck you in an answer, but the ratio is separate from the measure of corresponding angles for any similar figures, to triangles, to pentagon, to any polygons. If they are similar, the measure of corresponding angles are equal. Regardless, the scale factor is how much or small or big, doesn't matter. The x is supplementary angle of 132. The x now is 180 minus 133, which is 8 minus 3 is 5, is 47 degrees. Number 13, 47 degrees. Question number 14. I have equation of circle x minus 7 all square plus y plus 3 all square is equal to 1 in the xy plane. Circle B obtained by translating circle A to right 4 units. Shifting to right, you will do the opposite here. You will go to this and minus 4 from the x. So it will be x minus 11 all squared plus the same rest of the equation. So x minus 11 all squared plus y plus 3 all squared is equal to 1. Option C is correct. Next question here. Triangle ABC similar to triangle DEF where A corresponds to D and C corresponds to F. Angle C and F, right? Very similar question to for what we did right now. Just to draw the two triangles and make them similar by naming C and F and right angle, continue writing ABC like this, ABC, and DEF, you just write DEF. A corresponds to D, as you see, A and D are congruent angles, the corresponding angles. A corresponding to C, the corresponding to F, and C and F are right. Tan A is radical 3. Tan A radical 3, it means radical 3 over 1. DF is 125. What is the length of DE? First of all, to find the length of DE here, where is DE? Wait, I'm sorry. DF, sorry, DF. What is DF? Oh, sorry, DF is 125. Oh, sorry. DF is 125, not DE. Ask you about DE. To solve this question, you have to find, you have a tangent. The tangent is just ratio between sides, not actual length in question number 15. So if you want to find the length of DE, you have to find the length of AB first, okay? By applying Pythagorean theorem, consider the side now is what? Consider the side one. This is 1n. This is radical 3n. So this side is square n squared. I'll make it by 1 no, without n, no problem. So 1 squared plus radical 3 squared is equal to 4. So must be this is 2. So 2, 1, radical 3. This is the 30-60 triangle. If you remember, 2, 1, radical 3. So it's really, this is 30 degrees. This is 60 degrees, but the triangle is not drawn to scale. Of course, something like that. So how can you find the DE? The DE will be the same. This is 125. This is twice. This is 250. As the same as 1 is twice is 2. This side will be twice. So 250 is correct. The length of DE. Okay? You can solve by any other way. If you see something hard in my explanation, you can share with me your answer, please. What's the area of the triangle with the length of 17 centimeter and the width of? Just multiply 17 times 7 and pick the answer. Question number 16, answer is C, 119 square centimeter. Question 17, area of the equation of circle again, and the point is 6 and C, where C is a constant lies on the circle. What is the value of C? Direct substitution in the equation of circle, and you can simply, let me say, substitute with the point 6 and C. So 6 minus 3 is 3 squared, 9, 9 plus y minus 5 all squared is equal to 9. Removing 9, y minus 5 all squared is equal to 0. So y minus 5 is equal to 0. Consequently, y is equal to 5. And this is the answer. In the SAT exam, just enter 5 in the box provided below the question. Don't write y equal, don't write equal sign, don't write percentage, don't write as dollar sign, don't write full stop or question. Don't write any, just the number, just the answer. Length of rectangle diagonal 3, just to draw rectangle. And this is consider this is the diagonal of rectangle. 3 root 17. Root 17 is about 4.1, something like that. And the length of rectangle shorter than shorter side 3. Again, the length of the rectangle shorter side 3. This is 3 shorter side. What's the length of the rectangle longer side? The Pythagorean theorem, very simple. So this side is x, for example. So the x squared is simply 3 radical 17 squared minus 3 squared. So by solving this one, you get a square root, you will get the answer is 12. The answer now, x squared is 144. So the x is the square root of 144 is 12, the positive square root. Next question here. Question number 19. Triangle ABC and DEF are congruent, where A corresponds to D and B and E are right angles. So the measure of, just to draw quickly in your exam, these two to see the figure. And look at this one, look. Angle B and E are right. So just B and E are right and continue. Name the triangle ABC like A and B and C. The other one is D, E, and F. A corresponds to D. It's nice. Equal angles, corresponding angles. The measure of angle A is 69. This angle now 69 degrees. What's the measure of degrees of angle F? Angle F corresponds to angle C. C complementary with A. So the C simply 90 minus 69 gives you what? 1 and 9 minus 6, 21. So the answer is 21 degrees. Very simple. C and F, each one is 21 here, 21 here, because corresponding angles of similar figures are congruent, are equal. Length of rectangle diagonal 5, radical 17. Again, the same similar question for what we did right now. 5 square root of 17. The length of the rectangle shorter side is 5. What is the length of the rectangle shorter side? Longer side, as you can solve it by the same way by writing 5 root 17, but be careful, you have to make a bracket for all the number 5 radical 17 minus 25 and then take a square root. You will get the answer B. Answer will be 20. Question number 21. A circumference of a base of a right circular cylinder is 20. The circumference is d pi, so d pi is 20 pi, so the d is 20, diameter is 20, so the radius is 10. The height now is equal to 6 meters. This is meters, the same unit. What is the volume? The volume, as you know, is pi r squared h, or base area, multiplied by height. So the pi times r squared, 10 squared is 100, multiplied by the 6, it will be 600 pi. Very easy question. And the next one is a rectangular poster has an area 360 square inches. A copy of the poster is made in which the length and width of the original poster are each increased by 20%. So what is the area of the copy in square inches? Just to draw the original rectangle here, consider the dimension x and y. The area, the product of them is 360. xy equal 360. And if this rectangle a little bit enlarged by a scale factor 20, so the y will be 1.2y, the x will be 1.2x because it's enlarged by or increased by 20%. You add the 20% normally to the original percentage 100, that is the original percentage for any quantity, will be 120%. It means 1.2 of the original side. So I need the area now. So the area of this rectangle length I'm doing is 1.2x multiplied by 1.2y. So I have 1.2 squared multiplied by xy, and the xy already I know it from the first rectangle 360. Just multiply 1.2 squared by 360, you will get answer is 361.44. Okay, so I repeat again, 1.2 times 1.2 times 360 gives you, oh, something wrong. No, not this one, sorry. Not this one, not this one. Answer is 518.4. Okay, again, 1.2 squared multiplied by 360 gives you 518.4, and this is answer. Question number 23. I have a right triangle, angle x is the opposite side and the adjacent side 32. What is the value of x? Oh, to find the measure angle x by using SOHCAHTOA, I have an opposite and an adjacent. This is really the tan. The tangent of the angle x degrees is 32 over 32. Oh, it's 1. So the angle, so x is 45. This is half square. This really half square. This full figure is a square. If you draw other one, this is 32, 32. This is really 45, 45, and 45, and 45, and this is 90, and this is 90. So the answer is 45 degrees. Any right isosceles triangle. This is called 45, 45 triangle. And any 45, 45 triangle is right triangle. And any 30, 60 triangle is right as well. And these are two famous triangles, has some properties, special properties, not exist in other triangles. In triangle ABC, measure of angle B is 52 and measure of angle C is 17. What's the measure of angle A? Sum of all angles of a triangle is 180. So angle one of them, measure of angle A here is simply 180 minus 52 minus 17. Use it and depict the correct answer from this. And question number 25. In a triangle DEF, the measure of angle D is 47, measure of angle E is 97. The triangle RST, measure of angle R 47, and measure of angle S is 97. Which of the following original additional piece of information is needed to determine whether triangle DEF is similar? The first two angles in the first triangle, 47 and 97 degrees. And the second triangle, I have the same measurement, 47 degrees and 97 degrees. This piece of information is enough. So no additional information. So one of the famous theorems for two triangles to be similar, if two angles in the first triangle are congruent to the two angles in the second triangle, then the two triangles are similar. Because the third angle already will be the same, the sum of angles in any triangle 180, if you uh, assign or determine exactly two measurement of two angles. The third one already is known, which is 180 minus the sum of the given two angles. 7 plus 4 is 11, and this 14. The measure of the fourth angle here is 9 and 39 degrees. So the 39 degree, the third angle will be 39 here and 39 here. So all angles are equal, or corresponding angles are congruent. So no additional angles because we have already a theorem for AA postulate or angle postulate. In question 26, in a triangle RST, angle T is right, point L lies on RS and K lies on this one. This is parallel. All we have to do is this one. So draw in normal triangle like this, something like that. And again, triangle RST, angle T is right. This is T. So RST like this, RS, this is T. For example, this point, again, T is right angle R, RST, this is T, sorry. It must be T, not S, this one. Again, triangle RST now, angle T is right. Point L lies on RS. The RS here, point L, this is L for example. Point K lies on ST, this is for example K. LK, just to draw LK now, is parallel to RT. Yes, it's a parallel to RT. The length of RT 72, where is RT here? RT 72 units, and the length of LK 24. Now I have scale factors 24 to 72 for these two similar triangles. And the area of the triangle RST, the big one, is 792. The area of the triangle half base times height, half 72 multiplied by the height, which is the height now this side, which is ST. Half base times height is actually equal to 792. So 36 ST is equal to 792. So the ST now is 792 divided by 36, which is what this one? 792 divided by 36 gives you 22. So the length of this side is 22 units. Okay, the length of the side TS is 22 units. It will be the key now to determine the length of KT. Well, the length of KT in units, same units. I can, yeah. Since the two triangles are similar, so the ratio between 72 and 22, the two legs of the right triangle, the same ratio between 24 and SK, this side. So you can write SK over 24, the ratio between these two legs, the same ratio between the other two legs, 22 over 72. So SK, when you solve it now, you will get 22 over 3. 20, because this is really, you can simplify these two numbers. 72 over 24 is exactly 3. So the SK is 22 over 3. So the SK is 1/3 of the 22. So the KT is actually 2/3 of the 22, which is 44 over 3. And this is the length of KT or TK. 44 over 3. This is the answer. Next question here, for the very similar question for the one we did now. And I have a right triangle here. This circle pass through these points. and these points represent an isosceles right triangle like this one. Look, as you see here. Consider now there is a circle pass through this triangle. Always, if you have a right triangle inscribe it in a circle, the hypotenuse of this right triangle is representing the diameter of circle. So this is the length between five. This is what that's 4. This is 5, and this point is 11. Distance between 5 and 11 is 6. Or you can count the units 1, 2, 3, 4, 5, 6. So diameter now is 6 units of this circle. Okay. Circumference is k pi. Circumference of this circle is 6 pi. So the d equals 6. Or the diameter equals 6. So that's the answer. Thank you so much. Oh, no. This is delete all drawing and then delete this one. So next question is, what is the value of this? Sometimes when you calculate cosine, this big value gives you a decimal number. Even be careful, you can't, this 5, sorry. 565 pi over 6 gives you a decimal number, 0.8. I do it now by calculator, giving you something like that. You don't have this form. You try which one of these by calculator gives you the same decimal, you will find that radical 3 over 2. Or you can write this number as mixed number. You can write 565 over 6, and then in the calculator you press shift and the S to D, like this button. You will convert the 565 to improper fraction, as you see here. Yeah, if you write again 565 over 6 and press equal and then shift SDS, give me now 94 and 1/6. The 94 and 1/6 pi, when you just remove the even number of pi's here, you have left 1 over 60 pi. You have 6 1, you understand? So 1 over 60 pi, I mean, I really, yeah, I mean, 94 pi plus 1 over 6 pi. So remove this one because there's complete values of terms or complete terms about the origin. So you have only pi over 6, which is 30 degrees, and the cosine 30 degrees is radical 3 over 2. So anyway, you can solve, no problem. And the last question, or the one before the last one, is circle A. The xy plane has this equation. Circle B is the same center of circle A, and the radius circle B is twice. What is and this circle B this form? What is the case? So don't multiply 4 times 2. No, the 4 just write it 2 squared first, and go inside the radius, make it twice. Make it twice. Then you can write the answer as 16. So k is equal to 16. So if the circle enlarged to be like this, the center not change it. So the bracket of complete square will not be changed, it will be the same. Only k will change it from 4 to be 16 if the radius is doubled. Because you go inside the value or double it and then square the result to get the value of k. And last question, this one, a circle in an xy plane, its center 16, 17, has a radius of 7k, which equation represented the center. You know that the center radius form tells us the equation of the circle is x minus 16 all squared plus y minus 17 all squared is equal to 7k squared. So the correct answer is B. X minus 16 all squared plus y minus 17 all squared equal 49k squared. Thank you so much for watching this video, and I hope you get a full benefit from this one. Thank you so much, and enjoy studying math with me. Thank you. I am محمد زيدان. Goodbye.